Okay, so lesson 3, continuous and limits, and it is properties of limits. So on this first page, we have some properties, and these properties basically tell us what we're allowed to do with limits versus not allowed to do. And there's a lot of things you can do with limits in terms of how we handle them. So notice up there it says, there's times when you need to consider limits of functions symbolically, such as f of x, g of x, h of x. When you're given combinations, compositions, and other modifications of these nonspecific functions, there are important properties that will prove essential to these general function types. So, as we go through these, b and c represent numbers, real numbers, okay? N is a positive integer, and f and g are functions. So the constant rule. This just says the limit of a constant is going to be equal to that constant. Okay, so if you have, and it's the idea, if I draw a set of axes here, that, you know, here's my k line. Okay, the limit of anything on that line, if this line is y equals k, the limit of anything on that line is always going to be k. So the limit of a constant number is always equal to that constant number. Okay. Your identity rule. The limit as x approaches c of x is going to be equal to c. So it's almost like you can just think about plugging that c into the limit. And when you plug c in for x, it becomes just c. Okay, that's our identity rule. And that goes, you guys remember from pre-cal what the identity function is? The identity function was that perfect diagonal line that goes through what? 0, 0, 1, 1, 2, 2, 3, 3, so on and so forth. And so the limit as you approach x, well, keep in mind, what are the points here? We have a point, say, 2, 2. We have a point, say, 5, 5, right? So the x and y value are always going to equal each other. Just easy ones to be familiar with. Coefficient rule. If you have a number multiplied by the function, that number can be pulled out in front of the function. Okay. Sum and difference rule. The wording you'll often hear in calculus is the limit of a sum is equal to the sum of the limits. Okay, meaning, okay, if I have two functions being added within a limit, I can also break that up into two limits being added. So that's very much, you know, that's the wording you often hear. It's good AP form, but the limit of a sum is equal to the sum of the limits. So it doesn't matter which way you do that one. Product rule, you can use the same wording. Okay, the limit of a product is equal to the product of the limits. Quotient rule, guess what? Same thing, of course, as long as the denominator is not equal to 0. Power rule. The power rule says that, okay, if you have a power within the function, like on the whole function, you can also put it on top on the whole limit. Meaning, so we can do the limit and then take it to that power. This is the one we'll have to work with a little bit. The composite function rule. If you have a composite function, so where it's f of g of x. So if you remember from pre-cal, that's taking g of x and plugging into f of x. The idea here that we can pull that f out front, kind of a lot like the coefficient rule, right? We can pull that f out front and do the limit of g of x, and then take that answer and plug it into f. Okay? And then the root rule. Very much like the power rule, if you ask me. If you have a square root within the function or any root, it can be pulled out. You can do the limit and then take the root of it. Okay? So just some key pieces to be familiar with. Okay? So let's look at our examples. I started to zoom in and do half and half, but all these problems use the same two graphs, so I couldn't zoom in here. So use the properties to find limits of limits to find each of the following limits. If a limit does not exist, state why. Okay, so always be careful, guys. Word of warning. Pay attention. Which graph is F? Which graph is G? Because notice, what do they do within the problems? There's F and G within the problem, aren't they? So just be very careful. Easy to make that mistake. So as we look at A, you have a limit of a sum there. The limit as x approaches 3 from the right of f of x plus g of x. Now, if we apply our limit property, that means this can be rewritten how? The limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. And so the idea is you can take the limit of the sum and break it into the sum of two limits. And then it's doing what you've been doing, right? Practicing with these limits. So, as x approaches 3 from the right on f of x, what value are you thinking there? 6? Because we're going right up here, yes? And so that is 6. Well, that worked weird. Plus, now it's the limit as x approaches 3 from the right on g of x. 8. I'm down here. From the right of 3, I'm following to this open circle that is up at 8. Hard math here. 6 plus 8 is 14.
Did we do this last year?
Possibly. I always struggle with how much to remember. How much did we do with limits in pre-calc? We did a little bit. So I'm not going to say you haven't done it before.
Are we going to have to memorize the properties? Probably.
You need to understand and be familiar with them. Not memorize them to the point like you have to be able to write them down, but you need to be comfortable and confident with using them, would be my thought. Does that make sense?
Yeah.
Okay, so B. What do we see here? First thing that stands out is there is subtraction, right? Or that's the first thing that stands out to me. So I have two functions being subtracted, so I can split that into two limits, yes? But then what's also within each of those? Yeah, there's a coefficient or a constant being multiplied. So we can pull that 3 out in front of its limit and the 2 out in front of its limit. So when I write this, I'm going to go ahead and write this as 3 times the limit as x approaches 5 of f of x. That is if you guys can handle me doing this all at once. So I put f of x with its own limit. I pulled the 3 out front. I'm going to do the same thing over here. I'm going to pull the coefficient of 2 out front here. It's 2 times the limit as x approaches 5 of g of x. Okay, do the math, right? 3 is 3. I got the easy one for you. The limit as x approaches 5 of f of x. I can agree with 2. You guys see the 2 right here? So 3 times 2 minus 2 times, now it's the limit as x approaches 5 on g.
4.
Right there at 4. Three times 2 minus 2 times 4? Negative 2. Are we feeling okay about this so far?
Yeah.
Okay, stop me if I need to. C then. What do we have? We have a difference here, yes? The limit of the difference can be thought of as the difference of the limits. So the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches -5 from the left of g of x. These boxes are a lot bigger on my paper than they are on this BenQ screen. Okay, so what about the first piece? The limit as x approaches -5 from the left. Right there. I can go with 3. Minus the limit as x approaches 5 from the left on g of x. -5, excuse me. Mm-hmm. 3 minus 4 is -1. Okay. D, unless you stop me. The limit as x approaches -7 of 3 f of x over gx. So, I don't know. In my brain, it's pretty obvious that it's the same thing we have been doing, right? We're breaking into pieces. This is just a limit of a quotient. So we're going to break it into the quotient of 2 limits. And that 3 on top, though, can also go out front. So on top of my fraction, I'm going to have 3 times the limit as x approaches -7 of f of x divided by the limit as x approaches -7 of g of x. Three on top is 3. Limit as x approaches -7 of f of x. I agree. 5. The limit as x approaches -7 on g of x.
3.
I can agree there. 3 times 5 divided by 3 is 5. What's Logan doing? Okay. You got the pieces here, right? Have we done a product? I don't think we've done a product, but it's the limit of a product, so we're going to make it the product of 2 limits. And that 4 can go out front, yes? So we're going to have a 4 times the limit times the limit. So 4 times the limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x.
Are we multiplying everything by that?
It's just a single 4, and it's multiplication, so no, it's just a 4 times the limit times the limit. If that had been a 4 and then the limit plus the limit, you'd have to distribute the 4 or do your adding and then multiply by the 4. So no, there's just a single 4 there. Okay, the limit as x approaches 3 of f of x.
6.
Okay, I can be convinced of 6. The limit as x approaches 3 of g of x.
Say no.
Yeah.
No.
There's 2 sides.
Okay, so as x approaches 3, we've got to get going to 2 places, don't we? And so what do we know about the limit as x approaches 3 of g of x? It does not exist. And if that one piece of the limit does not exist, guess what? The whole thing does not exist. And I don't really have room to write it on here, but put it in words with me. Why did that g of x limit not exist? There's 2 points, right? What's the phrasing I've been using? The limit from the left does not equal the limit from the right. Yes? And I know that's what I know you guys understand why, but you know, be comfortable with that idea. The limit from the left does not equal the limit from the right. Okay? Okay, F, we have a power here. Remember the power? Basically, we can rewrite this so we're doing the limit and then squaring the result of the limit. So if I rewrite this, it's the limit as x approaches negative 3 of f of x. We're going to do that limit first, and then we're going to square it. So it is the limit as x approaches negative 3 of f of x. Yes? No?
6. Negative 6.
Negative 6? Unless you said it and I missed it. But yeah, get the negative in there. But negative 6. Then what are we doing? Squaring it. What is negative 6 squared? 36. G is similar, except there is a square root. Same idea. Do the limit, get that limit answer, and then take the square root. Now, we also have an 8 there, yes? So the 8 can go out in front of the limit. Now, and I don't care if you write the square root symbol, or what power is a square root equivalent to?
1/2.
1/2, right? So if you raise them into the power of 1/2, that's the same as taking the square root. Notation-wise, you can put either, but just for calculator's sake, it's always good to think about that. So this is going to be 8 times the limit of x as x approaches 4 of g of x. And you can write a square root, but I'm also I'm going to throw in there, it's raised to the power of 1/2, because that's a seamless transition we've got to know at this point. So we're going to do 8. What is the limit as x approaches 4 on g of x?
3 or 5.
5 is what I had. And then we're going to be doing the square root of 8 times 5. What are my options for how to express that? Square root of 40, or
2 square root of 10.
2 square root of 10. It's 4 times 10 is 40, and the square root of 4 is 2. Okay, H. The limit as x approaches negative 3 of f of x plus the limit as x approaches negative 3 of g of x. Well, I guess I'm going off the side. I wrote that too big to write underneath it. You guys have more room, so. The limit of the sum is the sum of the limits. So what about f? The limit as x approaches negative 3. Oh, did we just do that?
Yeah.
I still have it circled up there on the graph. Plus the limit as x approaches negative 3 of g of x. Oh, do we have a problem again? As x approaches negative 3. Oh, negative 3 is this asymptote here, isn't it? So we got one going down to negative infinity, the other side going up to positive infinity. So that piece does not exist. So what about this entire limit? It does not exist. And again, that limit on g did not exist because the limit from the left was not equal to the limit on the right. Okay, J. It's the limit of a quotient, so we're going to make it the quotient of two limits. The limit as x approaches 6 of f of x divided by the limit as x approaches 6 of g of x. Okay, what do we have here? Limit as x approaches 6 of f. 0. Divided by, what about the limit as x approaches 6 on g? 5. What is 0 divided by 5? 0. If 0 was in the denominator, we'd be talking does not exist. Okay. Or infinity. I guess I'd have to, we'll deal with that situation when we get there. Limit as x approaches -2 of f of g of x. We finally hit a composition, didn't we? We have more compositions later. So, this is a good practice one. Start by pulling that f out front. So, we're going to be doing f of the limit as x approaches -2 of g of x. So we're pulling that f outside. That's not that we're going to multiply by f, okay? It's composition. So we're going to keep that f outside, and then my goal is to figure out what goes in those parentheses. Okay, we'll deal with the f in a moment. So what is the limit as x approaches -2 of g of x?
Say -3. So,
Is it?
But from the other
or
side,
from, wait, so
because it's not from the left
-2.
and right.
Right.
Go from left to the right. Wait, we're talking g of x?
But also asymptotes.
But like, would it be -3? Because like technically the asymptote is coming up. You're going
The asymptote kind of goes
at.
So we're like the others, we're looking at the point here. It's just very close to that asymptote, so it's throwing us off. But so yeah, as x approaches -2 from both sides, we are leading to that point right there, which is -3. Yes. Sorry, when you guys were saying that, I was trying to figure out if you were talking about the asymptote -3 or the point -3, which is what I needed there. Now, at this point, we're no longer doing a limit. We're finding the value of f at -3. So what is the value of f at -3? -6. Okay. These go quickly at least, right?
I was doing all of this today.
That's my hope. And having some time to check homework. I mean, I guess we're about halfway through class, but this was the big page.
Yeah.
And are we getting quicker as we go here? Now, in all honesty, this page will be quicker because we're not looking at a graph, and the graph takes a little bit more time, and there's less on this page. But what we're looking at is they provide the information about the specific limits. The limit as x approaches c of f is going to be 3. That limit for g is going to be -2, and the limit for h is going to be 4. So they're telling you what the limit's equal to. You're plugging the information in. Okay, so it's still using our properties. You'll notice as you look at all 6 examples, it's always x approaches c, which is what they provided us, right? If it wasn't x approaching c, we'd have to talk differently. But so now, if I apply my rules here first. So the whole thing's going to be a square root, yes? Oh, well, okay. No going back here. So it's going to be the square root of all this. But it's going to be 3 times the limit of x approaching c of h of x minus 2 times the limit as x approaches c of g of x. Those pieces make sense? I'm using the properties, the same thing I was, whether you write it as one big square root or a power of 1/2. and start filling the pieces in. 3 is 3. What's the limit of h? Equal? And that's 4. Minus 2 times what's the limit of g equal? Negative 2. So 3 times 4 minus 2 times negative 2, the square root of all that business. Yeah, 12, and then it becomes plus 4, which is 16. The square root of 16, which is 4. And I hate to say this, but in a way, what would also save us a lot of time? Could you do this without writing the limits out? You could. And for your own personal work, that's fine. Now, if you are showing work on an AP, like the I always want to say open-ended, the free response questions, which is what the open-ended are, then obviously, you need to write out proper notation. But, if we want to shortcut this, what are we doing here? Yeah, we're taking the limit and doing those individual pieces here. So it's the limit. What's the limit of f of x? 3. Then there's a 5, right? What's the limit at g of x? Negative 2. If you're doing a multiple choice problem, there's nothing wrong with that, right? As long as you know how to do the actual notation. Which is why you won't always see me, avoid notation. What's this multiply to be? Negative 30. Okay, next. Guarantee. C. Limit as x approaches c of 7 minus g of x squared. I'm going to speed things up a little bit. Do you guys mind if I skip notation? You guys are probably, some of you are probably already skipping notation, aren't you?
So can we skip notation on homework?
Huh?
Do you want us to do it right now on
I
homework?
want you at least practice some with notation. Okay? Don't never practice the notation, because how do we learn it best? If we practice it. So maybe I shouldn't be giving you that out, but there's a lot of problems here, and it's getting repetitive, isn't it? So I understand. And you guys are in calculus for a reason, right? So nothing else, you passed pre-cal, right? Okay, so what are you guys doing on C? And I guess, well, one thing I should mention here. What about the limit as x approaches c of 7? What is that limit?
7.
That is 7, because I don't think we've used that rule yet, have we? So realize that that is 7. So on this one, okay, sorry, I lied. I'm going to limit as x approaches c of g of x. And I only did that because I want to make sure you guys realize that limit is 7. What is g of x? The limit at g of x is negative 2. And then what are we doing after we subtract these? We're squaring, yes? So 7 minus negative 2 is 9. And 9 squared is 81. I'm assuming you guys are going to holler at me if you don't like what I'm doing or if you're confused, right? That is my assumption. So please ask questions if there's something you don't like. D. The limit as x approaches c. 2 is 2. What's the limit of f of x? 3. Plus 3 times, what's the limit of h? 4. Over the limit of h minus the limit of g. The limit of h is 4 minus the limit of g is negative 2. Did I do my math right? Okay, matches my answer key. E. E, I think I am going to write this one out notation-wise because it looks a little different, doesn't it? There's an h of x, and then it's times f of x plus 6 in parentheses. So beware that what I'm going to do here is I'm going to say, okay, it's a limit as x approaches c of h of x. And then I'm going to say times, I'm going to use brackets, times, and then I'm going to have the limit of f plus the limit of 6. So the limit of f of x as x approaches c plus the limit as x approaches c of 6. So realize that one, we have h out front, and we have the other two in parentheses being added.
Why didn't you do that?
Huh?
Why didn't you do that?
Because if you look right here, f of x plus 6 is in parentheses. So this h is being multiplied by that whole quantity.
Okay.
Those parentheses are easy to overlook, aren't they? They kind of blend in. Okay, the limit of h, limit at h is 4. The limit at f is 3. What's the limit at 6? 6. So 4 times 3 plus 6? Yep. My brain said 4 times 9. Or maybe you did 12 plus 24. Okay. F. I'm going to skip notation this time. I think we'll be okay on this one. On top, it's the limit of f of x squared. So what's the limit at f? 3. So it's going to be 3 squared on top. Denominator. What's going to be the limit at 4? 4 minus, what's going to be the limit of g? Negative 2. My brain came up with 9/6, which reduces to 3/2. What do you think about example 3? Have you looked? Are you glancing? Does that look fun?
No.
No? Doesn't look fun?
No.
It's doing the same thing though, isn't it? Fun or not fun? I don't know. I like limits, guys. Sorry. Limits are fun. I like them. It's just breaking this whole big thing down, right? I mean, if I do my notation real quick, I'm going to have a 2 out front times the limit of f times the limit of g.
I'm confused on it with the 2 up front. Like, when do you do that?
What now? When to do that?
Yeah, like how do you know when to do that? Or like where to put it? Or is that just, that's always where we're gonna put it?
I mean, you could leave it in there, but here's the deal. What we have defined is we have this piece right here defined and that piece right there defined. We don't have a limit of 2 times f of x defined up here. Okay, so this is the coefficient rule that says if you have a coefficient out here, you can pull it out front.
Oh, I see.
Okay, so that was it the first, second rule, third rule? Okay. So that's the first piece. Then we're going to subtract. And this is going to be the limit of f. What is a curiosity here? What is a cube root? It's what power?
1/3.
1/3. Just reviewing. And then you're going to have 2 times the limit of g, and that limit's going to be squared. Okay. Again, you don't have to write out the notation there to understand this problem and do it. So, okay, I got 2. Someone else take the limit of f. 8. Someone else take the limit of g. -4. Then I'm minusing. And now I'm going to go ahead and put this under the cube. The cube root of f. What is f? 8. Plus 2 times the limit of g, which is negative 4, and we're going to square it. Okay. 2 times 8 is 16. 16 times negative 4 is negative 64. The cube root of 8 is what? 2. And then 2 times negative 4 squared, so 16 times 2, 32. My brain goes with negative 64 plus 32 is negative 32 minus 2. Or no mental math mistakes, negative 34. And my answer key agrees, so I must not have made the mental math mistakes. Okay, example 4. Compositions. I want some more practice with this. We've had one composition, and these are good. These are big, okay? These are things we need to know how to do. Given f and g, find the limit of f, the limit is x approaches 2 of f of g of x. So, first I'm going to use my composition function rule where I can pull the f out front. It's going to say f of the limit as x approaches 2 of g of x. Okay. Thoughts on that limit there? The limit of g. The limit as x approaches 2 of g of x. We don't have a graph we're looking at. And no, we're not going to grab the graphing calculator and graph it. Okay, we need to be able to do this without a graph. They give us an equation. What do you know about the equation g of x?
Negative 2x, so wherever there's an x in the top equation, but negative 2x. Right?
Not for the limit. No, I don't want to plug that in. I want to, right now what I'm working on is solely this part right here. Okay, we're not going to talk about f right now. We're going to talk about what's the limit as x approaches 2 of g. G is negative 2x. We're not going to graph it, but what is that graph? It's a line, yes? So we haven't talked a whole lot about continuous, but do you know what I mean when I say continuous? Is it a continuous graph where it's all going to connect? Or is it going to be like, well, which page was it on? It was on the previous page. Or is it going to be like these bad boys and jump all around? Okay, it's going to be continuous, right? And so the idea is if it is I'm going to use the word polynomial. This is a polynomial, yes. This is a polynomial, okay? These are continuous graphs, which means when I put my pencil down and I start drawing them, I can draw the whole thing out. With the fact that these are continuous, okay, basically to do that limit, you can plug the value in. Because g is continuous, in order to do this, we just need to find what g of 2 is. So when I plug in 2 into the g equation, what do I get? Negative 4. So right there, that limit is negative 4. And I can do that. I can just plug that in because it is a continuous function it works for. If it's not continuous, we have a different story to tell. But it's just a traditional polynomial, which makes it continuous. So now we're doing f of negative 4. What is f of negative 4? Oh no, do we have to do a little bit of math? Not that you have to write that out, but negative 64 minus 16 minus 16 minus 1.
You said negative 92. Oh.
Yep. No, you're fine. I wrote it without saying it on purpose. Because if you guys were doing the math on your own, you need to be able to do this kind of stuff without just grabbing for the calculator. Okay? I hate to be the bearer of bad news, but there's nothing that's very doable, right? I have to think, you might have to use some scratch paper, but we need to be able to do that. So I wrote it down with the idea of knowing some of you are still working on it and you'd want a chance to complete it. So, okay? Yes, I agree. Negative 97. I was waiting for someone to say it. So, yes.
The 2 from the G of 2 is from the limit, right?
This 2 right here?
Yes.
Yes, it was provided right there. Yes. Okay. Let's try B. Given F and given G. Same F and G. Oh, this time we're just switching it, aren't we? So this time we're doing the G of the limit as x approaches 2 of f of x. So we're doing G. And I want to know what that limit is. So what's that mean I have to find? We're doing the limit as x approaches 2 of f. Is f a continuous function? Is it a polynomial? It's variables with positive powers, added and subtracted, with coefficients, whole numbers. It's a polynomial. That's going to be some cubic equation, right? I don't know exactly, I have to know, but it's going to be continuous. Because it's continuous, I can just find f of 2. What is f of 2?
Okay.
So that's 11. So that means now we're doing g of 11. And what is g of 11? That math was a lot easier that time. Okay, one more section. This is taking a little longer than I thought. Okay. We'll adjust. 5. Last example though, right? Graphs of f and g to find the limits. The limit as x approaches 3 of f of g of x. So again, what are we doing here? F out front, and it's the limit as x approaches 3 of g of x. So, start on the inside. What's the limit as x approaches 3 of g of x? I agree with Ethan's finger. 1. We all agree with 1? Did you look at the correct graph? And then we're doing f of 1. Find the point, and I agree, negative 2. Getting the idea of function compositions here? Limits of function compositions? So B, it's going to be g of the limit as x approaches negative 1 of f of x. So g is going to stay out on the outside. The limit on f as x approaches negative 1. I agree. Negative 6. And then g of negative 6.
Negative 7.
I'm saying negative 7.
I have negative 7 down. Okay, now what's the catch here? My graph doesn't go that far, yes? Now, we would have an issue if this graph ended with a point. Does this graph end with a point? No, it ends with an arrow. So what does this graph technically do? It keeps going there, doesn't it? And so if you look at the slope, well, that's not, I'm going over 1, down 2, over 1, down 2. That should be putting you at -7. Okay? You looked at something wrong, didn't you?
Yeah.
Okay. This is the place to make the mistake, though. Okay, C. F of the limit as x approaches 1 of g of x. So now we're doing f of this limit. G. Okay, I'm getting too much junk written on G here. Need less junk. X approaches 1. What is my limit? Oh. Do we have a problem there? It doesn't exist, does it? So what's that going to be about this whole problem? Oh. No, what was the catch on this one? Hold on.
Are they in the same quadrant?
Okay, because this is a composition, I forgot about this detail. I'm not as familiar with this. And so I forgot about this detail. Because this is a composition, we have to check the left and right hand limits and look at a little bit at those. So now, what we've already talked about it. I'm going to write it down here. But we've already talked about the idea that the limit as x approaches 1 from the left, what's that going to be? As x approaches 1 from the left, we're going to be at -1, yes? The limit as x approaches 1 from the right of g of x is going to be -3. Now, we already knew that limit didn't exist, yes? I'm putting that down on paper. But what we have to do here is we have to look at these. Okay. Trying to remember. Because, and this is the reason, because both of these limits are coming from above. Okay. Because both of those limits are coming from above, we're going to look at the limit at f at that point, is what we're going to do here. So when we get to this -1, -3, can you agree that they are both coming from above? That makes sense when I say that, right? So because they are both coming from above, we're now going to look at the limit of -1 and -3 from the right of f of x. So let me write this down. Limit as x approaches -1 from the right on f of x, and the limit as x approaches -1. I knew that was going to happen. Shoot. Okay, you know what? I'm going to use it right over here. Limit as x approaches -1 from the left. Nope, not -1. What was the other number? -3. And from the, oh my gosh. Pause. Okay. Frustrated with myself, sorry. Limit as x approaches -1, because they both come up from above, we're doing them from the right side. Limit as x approaches -3, right here, from the right, because the graph was coming in from above. Now, let's look at those limits. And this is all because there is an f out here, right, that we're plugging these into. So if we look at f, the limit as x approaches -1 from the right. Where are we at here? We're going to be at -6. Okay, as x approaches -3 from the right, where are we going to be at? -6 as well. Our answer is actually -6 here. Okay, and again, This is a unique function composition problem, is what it is. Because these match, it's -6. If they didn't match, then we'd stick with does not exist. But because they matched, my answer is -6. Okay?
Does that work if it comes from the bottom?
Yeah, you would, if they were both coming from below, then we would just approach from the left is the difference.
So now we need to check that.
If they are coming from below, we would.
So if it's a composition and there's a DNE, then we check that.
Yes. Yes, and that's why we did it, because we ran into this does not exist. Okay, D. Limit as x approaches -3 of g of f of x. It's g of that limit, right? Limit as x approaches -3 of f. So it's g of, oh my gosh, someone's phone is going psycho. As x approaches -3 on f, what is that? -6. And what is g of -6? Oh, didn't we already did that?
I have no. I'm not that popular, so it's not me.
It's not.
I don't know if it's the phone ringing though, maybe.
Could it be from over there?
No, it's in this room.
Megan, could it be people going in volleyball? I don't have my buzzer on. I do.
Could be the football.
If there's a group chat blowing up, maybe. Okay. Homework that you need to do for Monday is lesson 1. What are we in? 3? 1.3.